All right, so in this video, we're really going to focus on the anatomy of a quadratic or the anatomy of a parabola. And so I want us to take a moment to just kind of refresh and review all this beautiful vocabulary that gives us language to talk about parabolas. So first things first, a parabola is the graph of a quadratic function. So any quadratic you're looking at would give you the shape of a parabola. It can vary a little bit, but essentially it's just a U shape. The parent function for a parabola is, of course, the very simple function y equals x squared. So again, a parent function is kind of your basic, building block equation that gives you the general shape, and the x squared is just the most basic general parabola equation. Okay, so for instance, when you're looking at this parabola here, you'll notice that all of this vocabulary is outlined for you very nicely. So we have our line of symmetry, where the parabola is symmetric on both sides of that. We can see our y-intercept is where it crosses the y-axis, x-intercepts where they cross the x, and of course parabolas can have 1, 2, or no x-intercepts. The point at your lowest space here, or possibly highest if your parabola were upside down, that's called your vertex, which recall comes from your HK value. Okay, so I included here 3 different forms of this one parabola. So take a look. I started with vertex form, which is x minus 1 squared minus 4. And we just see that from noticing that, oh, the vertex is actually at 1 comma negative 4. So this is at 1 comma negative 4. So if I were to plug that point into the vertex form, I would get this equation. Okay, factored form, same idea. I'm just looking at where the x-intercepts are on this graph. So I can see one of them is at negative 1. So that gives me a factor of x plus 1. The other x-intercept is at positive 3, which gives me this factor, x minus 3. So remember, you're thinking in terms of if I plug in 3, 3 minus 3 is 0, or negative 1 plus 1 is 0. Because I'm really looking for those x-intercepts to be values that make my equation equal to 0. Okay, and then standard form can be found if you multiply any of these out. So like, for instance, if I wanted to just multiply out factored form using a generic rectangle, then I would get something like an x squared plus x minus 3x minus 3, and adding all those together, that gives me x squared minus 2x and then minus 3. So notice how that is my standard form. So you can kind of work forwards and backwards with standard and factored form, vertex form, all those beautiful things. Okay, so down here, I just gave you guys a vocabulary bank so you could reference those things quickly and, hey, maybe quiz yourself. Do you know what each of these things means? And then over here, just a quick reference box to talk about how to find intercepts. So recall that when you're finding a y-intercept on your y-axis, like right here, you would plug in x equals 0 and evaluate that. To find the x-intercepts, so that would be like these two here, that's where you have to plug in y equals 0. And this, of course, requires factoring. Okay, so I'm going to give you examples of each of these things on the back so that you feel comfortable finding your intercepts and finding your vertex. So let's flip the page and go there now. You're going to need all of these skills when graphing a parabola. You have to know how to find your y-intercepts, x-intercepts, and vertex. So I'm going to do one example and clearly explain how to do each of those things if you're not quite sure or you don't remember. So in graphing a quadratic function, you must find each thing. We're going to work with this equation here, x squared minus 2x minus 8. Okay, so to find a y-intercept, recall, plug in x equals 0. So in this equation, it would look something like 0 squared minus 2 times 0 minus 8. Those, of course, just become 0. And negative 8 is my y-intercept. Now, we talked about that earlier on in this unit, that your c value is always your y-intercept. But in case you forgot, that's an easy way to make sure you know. Okay, so next thing we're going to do is find our x-intercepts. So remember that to find x-intercepts, you plug in y equals 0, and it's going to require factoring. So let's do a little factoring work on the side here. I'm going to rewrite the equation just to make sure I don't get it wrong, and then start factoring with the box and diamond method. So if I set up a generic rectangle, the first square term goes in the first box, the -8 in the last. And remember, you multiply those together, and I get -8x squared. But I'm looking for two terms here that add up to -2. Because essentially, all these boxes have to add up to what I have here. Okay, so what are those two numbers? Probably -4x and +2x. Those are going to multiply to 8, but add up to -2. It doesn't matter the order you put them into the boxes. And now we factor out what they have in common. So these two terms only share an x. These two, 4 goes into both, and since they're both negative, I'm going to pull the negative out along with it. And then up here I get an x and a 2. So my factored form is going to look something like x plus 2 and x minus 4. And at this point, I actually want to plug in 0 for y and just make sure that I know how to solve for my x-intercepts. So what are the values that make x plus 2 equal to 0 or possibly x minus 4 equal to 0? Those, of course, are going to be -2 here if I subtract and +4 over here if I add. So that means my x-intercepts are at -2, 0 and also at 4, 0. So notice how if I were to start graphing my equation already, I'd have pretty specific values for x-intercepts and y-intercepts. And the last thing I really want to do is find my vertex. So the vertex is going to take a minute. I have two options for you to do this. Okay, so option 1 requires averaging your x-intercepts. So average the x-intercepts and then find y. And this is playing off of the idea that your x-intercepts actually are symmetric. So if I go back to a picture of a parabola, notice here that right in the middle of my x-intercept, so one here and one here, right in the middle is my line of symmetry. And on my line of symmetry is the vertex. So I'm playing off of that idea. So to average these, I'm going to take my option 1 here and just say it would be -2 plus 4 all over 2. So I'm taking the average of two numbers, and it's going to be equal to my h value, right? Because my vertex is going to be like h comma k. So that gives me 2 over 2, which is 1. And then to find k, you essentially just plug this back into your equation. So the x squared, so I'm going to plug in 1 for my x, and 1. So notice here I'm just plugging it into the equation to find my y values. And I'm getting 1 minus 2 is -1, so -9. Okay, so that's one method, and that means my vertex is going to be 1, -9. But there is another option. And the other option is essentially to complete the square and put it into vertex form. Okay, so let's take a step doing that. This one might take a little bit longer, so you can pick kind of your favorite method to do. Okay, so in this one, we're going to start with the equation itself, -2x, minus 8. And when I complete the square, I need to start by adding 8 to the other side. And I kind of have this empty space where I'm looking for, how many tiles do I need to complete the square? Because right now, essentially, my area model would have 1x squared in it here, or 1x squared, and then -2 of these x's. So there's a -x, here's a -x. So how many tiles do I need to add to complete my square? Just 1. So I'm going to add 1 here, and I'm going to add 1 here. So I have to preserve balance on both sides. So on this side, I get y plus 9. And over here, I'm now going to change into writing my area as a product. So it's x minus 1 squared. And then subtract a 9 to the other side in order to get y by itself. And I can see that in vertex form, my vertex is what I thought it was before. It's going to be +1, comma, -9. Okay, so all of these skills are things that you need to know in order to be able to graph a parabola in a really specific way. I know what my vertex is, I could plot that. I know what my x-intercepts are, I can plot those. I know what my y-intercept, I can plot that. And then I have a really specific graph for my parabola. So refer back to this sheet as you go through your work and make sure that you're successful in finding all of these key features.